All right, so for today, we are basically doing a review of the last three sections that we've had for unit number 7. So there's three topics that we're going to talk about. We're going to talk about the Pythagorean theorem, the special right triangles, the 30, 60, 90, and the 45, 45. And of course, we're going to be talking about our friend SohCahToa. So let's get started. Remember, you're going to take a couple notes here, and then you're going to try some of these problems on your own. So let's begin. Now, for the first part here, it says, find the missing side of each triangle, leave your answer in simplest radical form. So for the first page of this assignment, when I look at this picture, I see there's one side, two sides given to me. I'm only missing a third side. And when you're missing a third side, this is a perfect candidate for Pythagorean theorem. Now, in the Pythagorean theorem, it's very important to recognize who the hypotenuse is, and it's very easy to spot. Look at that 90-degree angle. It's basically that little 90-degree angle. It's almost pointing to where the hypotenuse is. Remember, the hypotenuse has no contact with the 90-degree angle, and that's the value that goes on its own. While on the other hand, the legs are the sides that actually create the 90-degree angle. That's why it's easy to spot who the legs of the right triangle are. And notice they're the ones that go with the plus sign. So we're going to apply this rule. And yes, there's another concept called Pythagorean triples. When you did this homework a while back, if you got nice whole numbers, no decimals, no fractions, we would consider it a Pythagorean triple. So let's begin. When I'm looking at this very first problem here, and we're going to leave the Pythagorean theorem right next to it, my first job is I look here, and then I say, hey, look, this is the side that has no contact with that 90. So obviously, this is now my hypotenuse. This is the height, which makes these two the legs of my right triangle. And so now that we've kind of split it up a little bit, here's where my Pythagorean theorem comes in. The Pythagorean theorem says a squared plus b squared is equal to c squared. And the most important thing is, notice when I set it up again, I leave parentheses to a power 2 nice and blank for me to fill in the appropriate information. Just remember, the one that's all by itself is always the hypotenuse. And so my hypotenuse in this picture is an x. Well, then I'm going to put an x in that spot. And of course, the one with the addition symbol, these are the two legs. Look at that, a and b go with the plus sign. So 4 and 9. And if you accidentally put 9 and 4, you would still get the same answer. And so now we're going to give everybody a power of 2. Now keep in mind, this is not 4 times 2, it's 4 times 4. So this is 16. 9 times 9 is 81. And of course, x squared is x squared. We don't get rid of the power of 2. Now, these two are already on the same side, so of course, we're going to start just combining like terms here. And when I combine the 16 and the 81, we get an answer of 97 when we combine these two right here. And of course, it still equals x squared. And then we bring in our pretty much our last step here, which is what gets rid of a power of 2? Well, in math, there's only one thing in this world that can get rid of a power of 2, and that is, of course, a square root. So we square root both sides, and we have x is equal to, now it says the square root of 97. Yes, this is where we'd let a calculator come in and guide us a little bit. So we go the square root of 97. And notice we end up with a decimal answer. If you get a decimal, this is definitely not what we called a Pythagorean triple earlier, because it's not a nice number. And so when we get a decimal like this, we prefer to leave our answer as the square root of 97. As the calculator showed, you can't reduce a square root of 97. But then that's it. That's how Pythagorean theorem works. Now, there's a big misconception with the Pythagorean theorem, which I'll show you on this one. They gave me two sides. I'm missing one side. Perfect candidate for the Pythagorean theorem. And so I'm going to do what I did before. I always like to locate the hypotenuse first. Here's the 90. Here's the side that makes no contact with the 90. So clearly, this is my hypotenuse. So these must be the legs of my right triangle. All right, so here comes the Pythagorean theorem again. Now this time I'm going to go right into my parentheses with a power of 2 plus parentheses to a power 2 is equal to parentheses with yet another power 2. This is how it all starts. But here's the common misconception. People always think, oh, the letter, the x, always goes out here on its own. That's not the rule. The rule is the hypotenuse is what always goes out here on its own. And when I look at this picture, the 12 is the hypotenuse, then that's where we put the 12, which means the legs, the x and the 11, they would go with the plus sign. So remember, order does matter. The hypotenuse should be the value that's squared after the equal sign. So now I'm just going to work it out. X squared is x squared. 11 times 11, 121. And 12 times 12 is 144. Now, unlike here, where we combine them immediately, this time I do have to bring in a little bit of algebra, bring in the inverse, and I subtract the 121 from both sides, leaving me, of course, with x squared is equal to, well, let's do the math here, 23. And of course, just as we mentioned earlier, the one thing in math that can get rid of a power of 2 is a square root. And yes, the power of 2 and the square root are inverses. They cancel each other out, leaving me with the x on its own. Now, the square root of 23, let's see if that works out, because we should always check. So the square root of 23 is equal to, and there it is. Look at that. That's not a nice answer, right? It's a decimal. Well, they never said anything about rounding. They said leave your answer in a simplified radical form. There's my exact value. So no decimals here today. Just give us that radical that belongs as our solution. So this is Pythagorean theorem. Once again, as a reminder of how it works. So right now what you should be doing, we're going to pause this video for a moment, and you should be working on numbers 3 through 6 in this worksheet. Now that you've had the opportunity to work on numbers 3 through 6, you should be checking your answer with your neighbors, but most importantly, check it with the key that the teacher has. So now we'll go on to the next topic. Now, the next biggest topic that we've had has been this very special set of triangles. So it once again says, find the missing side lengths. But you're going to leave your answer in radicals in simplest form once again. But now these are a very special case, because if you notice with these first two, I see a 45 and I see a 90. I see a 90 and I see a 45 for this one. Then I don't want to bring in Pythagorean theorem. One, because I can't. I'm missing two sides, so Pythagorean can't work. But I already recognize that in my word wall, I can bring in the concept of what a 45 degree 90 triangle is. And if you have to twist it around, we'll twist it around so that it matches this one. But remember, these are the ones that follow the special setup called the leg hype, right? LLH. So once again, the most important thing for me to do is figure out which one of these is the hypotenuse. Well, here's the 90. Go straight across. There's the hypotenuse, which makes this a leg and a leg. And remember, the technique that we're using in class, we're going to use the rule instead. We're going to go leg, hype. I'm going to bring in my formula for leg, hype, which is K, and K square root of 2. Because of the Pythagorean theorem and the rules that we've talked about, we know the hypotenuse is always the scale factor times radical 2. Now, again, I look at my picture and I say, okay, that's not a number. That's not a number. Here's the only number I have, 6 radical 2, and it's the hypotenuse. So I will write it right here, 6 radical 2. Now remember, when you're done doing this, we don't need the word wall anymore, but we can definitely, I'm gonna cover this up. We don't care about the U and the V yet. My concern is, can I fill out the 2 legs? Well, think about it. It says radical 2. Here's the K. Then K must be the number 6. And if K is the number 6, then anywhere I see a letter K, I'm going to put a number 6. Well, look at that. I see a K right here. Then I'll put a 6. I see a K right here. Then I'll put a number 6. Again, Don't worry about what letters are in the picture. You need to figure out what the legs are here. And now that I've done that, now I can go into my picture and go, hey, here's a leg. I get to put a 6 here. Here's another leg. I get to put a 6 right here. And now I can answer the question. The question is, what does U equal? 6. What does V equal? Well, there's a 6 there. And those are the two answers they had been looking for. But we use the rule instead of that formula that we had in the past. We're using a rule to help guide us in trying to find these answers. Now, the 45-45 is easier. Wait till we get to the 30-60. So here we go again. Look, here's a 45. So this is a 45-45. So here I go. This is my hypotenuse. This is the side that doesn't touch the 90. That makes this the leg and the leg. All right, here comes my rule. Leg, leg, height. My formula or my rule for leg, leg, height is the scale factor K, K, K radical 2. And now the only number that I see in this actual triangle, and I'm not talking about the angle, the only side I see is the number 5. Notice how they wrote it with the letter L. Well, here's an L, then I'm going to write a 5 right below it. And just like that, look at that connection. K is 5. So anywhere I see a K, I'm going to put a 5. I see a K right there. Then I'm going to bring a 5 into it. I see a K right here. Then I'm going to put a 5. But remember, the hypotenuse is special because it's multiplied with the square root of 2. There. Again, you see, I didn't look at my picture. I don't care about X and Y. Don't bring the X and Y in here. This should be all numbers only. And now I'm ready. The other leg is a 5. Here's the leg. I'll put the number 5. My hypotenuse is 5 radical 2. Well, here's the hypotenuse. 5 radical 2. Bring the information back into the picture, and now you can answer everything very easily. X is 5 radical 2. The Y, well, the Y is equal to 5. And I'm grabbing that all from my picture because I took the time to use the rule first and then brought this information back into my picture. Now, the same goes for the 30-60. The 30-60 has a very similar, right? It has a rule that we're going to be applying. And so when I'm looking at this picture, once again, yes, I see a 90. And there's a 60. So this is officially a 30-60. Look at this one. I see a 90. And yes, I see a 60. So I can apply the 30-60 rule. But we have our own special technique for that as well. So let me remind you. So here's the 30-60-90. We said we're going to go with a classic small, medium, large, right? There's a short leg, long leg, hypotenuse. But some people, we want to change up some of the letters to make it easier for some of us. So we're going to go small, medium, large. So when I'm looking at this, this is clearly the smallest side. This is the largest side. It's the hypotenuse, which makes this the medium. All right, but I'm going to bring in my formula. Small, medium, and large. All right, let me bring my formula in just like I had before. It says K radical 3, and 2 times K, or 2K for short. Now, it's time to spot the number. What's the only number that when I look here, what's the only side, I should be specific, what's the only side they actually give me? Well, they gave me an 18. And notice how it's connected to the L for large. That means here's the L for large. I'm going to put an 18 right here. This is the only time, right? This is why it's a rule. It's the only time that I would use these two. Notice K is not 18. That would be wrong. 2K has to be 18. And if 2K has to be 18, well, look, divide by 2. K is equal to 9. There's the scale factor. I can now bring this 9. Anywhere I see a K, I'm going to bring in the number 9. So I see a K right there. I'm going to put the number 9. Remember, I don't care about this picture. Let me block it out. We don't care about that right now. K is 9. There's a K. Then I put a 9, but this requires a radical 3 attached to it. So now I officially have every side of the triangle. So let me go back into the picture and put them where they belong. The small side is 9. There it is. The medium side is 9 radical 3. And just like that, I'm ready. Look, I don't have to do any more work. The x is 9 radical 3. The y has a 9 attached to it. And those are the two answers they wanted. So we're going to try one more of these. Again, these are the ones we need to practice from, or practice for. So here I see this triangle again. Well, here we go. This is the smallest side. This is the 90, so that must mean this is the largest side, which makes this the medium. All right, S, M, L. And here comes my formula, the never-changing rule. K radical 3, and 2K. And the only side they gave me, the only one with an actual number is this one with the medium. All right, here's the medium. Then I'm going to write it right here, 4 radical 3. But you see, this one's not, we don't have to do what I did over here. Remember, over here we were dividing by 2 because 2K was 18. We don't need that one on this one. Check it out. There's the radical 3. So that means your K must be that number 4. So now everywhere I see a K, I'm going to put in a 4. I see a K right here. Then I'm going to put the number 4. I see a K over here. Now watch out over here. It's not 2K equals. No, the K is the actual 4. And because it's next to the 2, yes, that's multiplication. 2 times 4 is just an 8. So I'm ready to bring that information into my picture. The small is 4. The large is 8. And just like that, here comes my answer. X is equal to, I have an 8 there. Y is equal to 4 because I wrote a 4 there. All right, so we're going to pause the video one more time, of course, and you're going to work on the rest of this side of the worksheet here. So 11 through 14, try those out using what we just talked about right now for numbers 7 through 10. Okay, and finally, now that you've worked these out, and again, you should have checked your answer for numbers 11, 12, 13, and 14. Then let's finish up today's review. And we only have 2 more problems to go. These are the we do problems. So it says find a missing side. Notice that's not a 45-degree angle. It's not a 30 or a 60. So that special rule doesn't work. This one's not a 30, 60, or a 45. So no special rule on these. The other thing we notice is I only have one side. So Pythagorean doesn't work either. That means this is where our friend SohCahToa is going to come in to help us out for these problems. But remember, in order to allow SohCahToa to help us out, we should be labeling our right triangle. And when we label our right triangle, it always starts with an angle. Well, here's my angle. Here's my 90, which means this one is the hypotenuse. Now remember, we're not going to go LLH. We're not going small, medium, large. No, we're labeling for SohCahToa. This is my hypotenuse. The 17, look how this side has no contact with the 48. That makes it the opposite, which of course makes this side the adjacent because it's right next to the angle. And so second step, step number 2, I circle what I'm looking for. I'm looking for X. And I circle what was given. They gave me a 17. What they didn't give me is an adjacent. Well, that's great. If they didn't give me adjacent, then I shouldn't use the letter A at all. So look, this has a letter A in it, then I won't use that one. This has a letter A in it, then I won't use that one either. I now know that the winning trig function is going to be sine. S-O-H, don't forget S is for sine. But of course, what has to be right next to the sine? What's the angle? Remember, it requires an angle for survival, so it needs that 48 right next to it. And now here comes our fraction. And when you're setting up our fraction here, remember the rule. It says O and H, opposite. O and H, opposite is 17. The hypotenuse is X. And remember, one of our techniques that we can use to solve this is we can use cross multiplication, as some of you like to call it, the butterfly technique. 1 times 17 is 17. But then when you do this one, x times sine of 48, well, then that's x times sine of 48, which means technically we have one more step to take. X is not by itself. We should be dividing. So I'm going to divide by sine of 48 to both. See, that gets rid of everything. The x is officially by itself, but be careful. This is exactly how you type it in to Desmos. Use that fraction. So here's our very Desmos-like calculator there. All right, so here's my fraction like I would do on Desmos, 17, and then at the bottom, the sine of 48. And so they did say round to the nearest tenth, so my cutoff is the 8. So my answer is either 22.8 or 22.9. Well, that 7 next to it is telling me to round it up, so we're going with 22.9. And there's my answer. All right, let's try this one last time here. So for number 16, once again, here we go. I need to know which one will be the winning trig function for this one. Only way to figure that out is to label. So there's my angle 51. That makes this side the opposite because it doesn't make any contact. Look at that. This side doesn't touch that angle. Now here's the 90. So there's the hypotenuse. And of course, my adjacent. I always like leaving the adjacent to the end because opposite is easy to spot. Hypotenuse is also very easy to spot. And now it's time to circle. I'm looking for x, so I'll circle this side. They gave me a 13. I circle this. Remember, the angle, we don't circle that. That means hypotenuse, nothing was given to me about hypotenuse. So anything with an h, right, we crossed it out, then this one's gone. And because this one has an h, that one's gone. This is the winning trig function. T, of course, stands for tangent. But I don't start with O and A yet. That's later. That's after the equal sign. Tangent of 51. Remember, we need an angle. For trig to survive, we need an angle right next to it. Here's my fraction. And then it's opposite over adjacent. Opposite over adjacent. X over 13. Now, we put our little fraction there. Put a little 1 under it. And now we can cross multiply this. So when we cross multiply, 1 times x, well, that's just x. And then when I cross multiply this, 13 times tangent of 51. Remember, don't multiply the 13 and the 51. No, write it. 13 times tangent of 51. And this is exactly how we type it into the calculator. Get that Desmos scientific calculator going. Here's one very similar to it. So it says 13 times tangent of 51. Now my answer is either 16.0 or 16.1. Well, because it's a 5, we're going with 16.1. So again, those are the 3 things that we've learned so far when it comes to right triangles. We have to know which technique to use, but you now know how to complete the rest of this page using a little bit of our friend SohCahToa. All right, make sure you're checking your answers for these problems, and when you're done, drop it off into the homework box and you're all good to go with today's homework after that. Have a wonderful day, everybody.